In project risk management, let's combine quantitative risk analysis using expected monetary value with risk response development. This style of risk register flows naturally when entering probability in percent and impact in dollars. For this exercise, I was inspired by my participation in a client's risk management meetings, and I came up with this hypothetical situation and style of risk register somewhat modeled after theirs. So imagine that you have identified a risk, and the risk is that your user requirements might arrive late. And you and your team estimate there may be a 50% probability of this happening. This is fairly high, actually. Some of my corporate clients would say if the probability is 50% or higher, you should plan that it will happen. But in any case, you expect that impact, if it happens, is $200,000. Sometimes it's unrealistic to come up with a single point impact like this. It could actually be a frequency distribution of possible different impacts. But for the purpose of this style of risk register, we have to guess at a single point impact amount. Clearly, the expected monetary value of the risk event is 50% times $200,000, or $100,000. And you and your team have given some thought to your response strategy, and you've decided to mitigate by spending 200 hours more in requirements definition. At a rate of $100 an hour, your mitigation cost would be $20,000. It would cost you $20,000 to reduce the probability and or impact of this risk. Now, your fresh estimate of the probability in column G is 25%. This is a fresh estimate. There's no arithmetic involved. And your fresh estimate of the impact is $100,000. Again, this is a fresh estimate. There's no arithmetic involved. But your new expected monetary value involves arithmetic. 25% times 100,000 is $25,000 expected monetary value. The $25,000 is a handy single number to represent the risk. And therefore, if you carry out this mitigation strategy, you have made an improvement to the expected monetary value. You've improved it from $100,000 to $25,000. You have made a $75,000 improvement. But you deduct the $20,000 that you had to pay, and there is a net improvement of $55,000. Well, this seems rather attractive, and it would seem sensible that this is a good idea and that you should do the mitigation. Now, in real life, practically speaking, you should consider other mitigation strategies which might compete and might be even better. Now, another question I have for you is, what if after we went through this arithmetic, the net improvement was a negative number? Say the net improvement was minus $5,000. Would you do the mitigation? Well, it depends on your risk tolerance. If you're risk neutral, you may say, no, it's not worth it. We'd be spending more than the amount that we would be reducing the risk. But if you're risk neutral, in other words, you just don't want to have this this risk event happening. Maybe it would be embarrassing, or you can't handle the $200,000 of impact. Then maybe you would decide to carry out your mitigation strategy even if your net improvement is negative. So this is just a simple example of combining quantitative risk analysis with risk response development.